Hello everyone. So today in this video, we are going to start our deep learning series with the mathematics behind CNN, Convolutional Neural Network. That what mathematics does this neural networks has at its back and what kind of features does it contain in the filtering process, in the kerneling process, in the pooling process, and in the striding and padding process, how it handles the matrices and take out features in from that exactly what we require. So without a further ado, let's get started. So for the mathematics behind CNN, we are going to start with a basic topic into it, which is known as kernel. Kernel is used to extract the features and it is used as a convolutional layer. Now, if we have a simple image of input size of 5 by 5 and a kernel size of 3 by 3, so how we are going to handle that? Starting with that, if we have that kind of image, so we are going to select the same 3 by 3 matrix from the 5 by 5 matrix and multiply that with the kernel sized, and in the multiplication we multiply same matrix on the basis of their indices and do their summation as well. And over here we are doing their summation, so it would be almost about 12, and it would be the multiplication of first 3 by 3 matrix and this kernel 3 by 3 matrix, and its answer would be 12. Now for another multiplication, we have done it just for the single ones. For the second one, we are going to move a single row forward, or you can say a column forward. Then the same these values would be multiplied with this one, and the answer would be the same one as the previous one, 12. You can also calculate it for your confirmations. Then for the next one, we are going to move once again a bit forward and the answer would be 17. Then we are going to move a single row downside, and then we are going to multiply that 3 by 3 matrix with this matrix and the answer would be 10. And then we are going to move forward and all, and we are going to create a feature map of 3 by 3 matrix which would be looking like this. This all was kerneling. Now as we have got the feature map, what would be the formula to get the size of the feature map? So it would be I minus k. I is representing input and k is representing kernel. 5 minus 3. Input is 5 by 5, kernel is 3 by 3. So 5 minus 3 plus 1. So it would be 3. So the answer or the feature map would be of 3 by 3 matrix. Now our next topic is stride. Stride is nothing just more than it just moves this our 3 by 3 matrix 2 times than the kerneling. Kerneling was moving a single column or a single row. It makes it move 2 times, 2 rows and 2 columns. That's the basic difference between kerneling and striding. So its final matrix would be of 2 by 2, and if we look at its formula, so it's I minus k means 5 minus 3 divided by stride. Stride is of 2 times, so it would be 2 and plus 1. So 5 minus 3 would be 2, 2 divided by 2 would be 1, and plus 1 would be over here 2. So that's a mistake. You have to write down that in the comment section that what mistake we have done over here. What number we have written instead of 2. Now as we already know the kerneling and striding, now padding. Padding is used to handle the corners. the corners information, image of the corners information. We do it through giving a zeros all over our matrices, and we are going to have the same matrix as our input matrix. With the help of that, we're going to look at its formula, which is I minus k plus 2p. P is presenting over here padding, which is moving a single stripe, so it would be covering what? Single value, which is 1. Then stripe is also 1, so it would be the 1 plus 1. So it would be 5 minus 3 plus 2 divided by 1. So it would be 4 over here plus 1 would be the 5. So the final matrix would be of 5 by 5, which we have already extracted over here. Then we have pooling. So pooling is used to reduce or to extract only important features. Kerneling was also extracting features, but pooling is used to extract only important features. Here there's a mistake of spelling in a word. Please let us know in the comment section which word is that. Over here we have the same formula, we write it. Now we are taking a pooling. Pooling is of 2 by 2 matrix, so we would be taking 2 by 2 matrix. So from over here, now from over here we are going to take the max value, because we are looking for max pooling. So it's what? 14. In the next 2 by 2 matrix, let's see what is the max value. It is of 17, so max value would be the 17. Now as we don't have a 2 by 2 matrix over here, so we would be moving over here on the downside, and our max pooling value would be 11, and in the next one it would be 19, and the whole matrix would be of 2 by 2, and it's drawn in front of you. Now as we know, pooling has two techniques, max pooling and average pooling. So average pooling would be taken with the same way, but it would be the average of all the values, addition of all the values divided by number of values. So it's pooling, average pooling. Now as we know what each and every function is, now we are looking at this problem. We are giving an input of 28 by 28 pixels as an input image. Now we are using kernel of filter 32, which is always constant, whichsoever we are giving, that number is constant, and 3 by 3 matrix of kernel. So its size would be 28 minus 3 plus 1, so it would be 26. So over here the size of the image is reduced to 26. Now pooling means we have to divide 26 by 2, because we are taking over here 2 by 2 matrix, so it would be 13. So now the shape or the pixels in the image are 13 by 13. And then we are using another kernel or another convolutional layer. So 13 minus 3 plus 1, so it would be 11. Now the image size is 11 by 11. Now the pooling size, once again pooling layer, so it would be 11 divided by 2, which would be 5 by 5, and we would be considering 5. Now finally the image size is 5 by 5. The 64 is over here, we have provided a filter of 64, so over here we have 64. Now we are going to convert 64 multiplied by 5 multiplied by 5 to flatten in just a single dimension, and that single dimension we are giving as an input to our neural network to handle it very easily and to read the features it has extracted through kerneling, padding, striping and all. So that was it for today, guys. We will be meeting in the next video. Until then, keep understanding such kind of concepts. Until then, keep trying to understand such kind of concept. If you doesn't understand a single concept in today's video, so don't worry, rewatch it. And if you still don't understand, write your queries in the comment section. We will be meeting in the next video with hands-on practice on convolutional neural network. Until then, see ya.